is. So. Okay, yeah, so I don't know about ice cream. I don't know about all the nuance things because this is a relatively, we don't even ask this type of question at Allegheny campus. We do like a replacement volume question, meaning like they did a collection of like a urine output, and then we're calculating fluid volume. This, I think, is just another reinforcement of calculating the volumes that are being calculated. So let's just work through this real quick. Actually, go ahead and you can start working on your own and see if you get an answer similar to what I'm going to get. So don't wait on me. So to go ahead and then once you get an answer, put it into the chat, or you can even, if you don't want to commit to your answer, you can send it to me as a direct message, and I won't call you out if you get it. I won't call you out if you get it right or wrong. So. All right, so while you're all working on that, remember it tells us here, we have to know what the glass is. So I know at my house, we have tall glasses and short glasses and fat glasses and skinny glasses. So what kind of glass are we talking about? So this is an 8-ounce glass. So one glass of orange juice is 8 ounces. And we need to convert that to milliliters. And I'm going to do that by multiplying by 30. Because you know, and I know, that 8 ounces is the same thing as 30 milliliters. You also know that 8 ounces is the same thing as 1 cup, and 1 cup is 240 milliliters. So it's always a good review of what these things are. Okay. The coffee, they tell us specifically it's 12 ounces in this case. Was that? I was going to say I should have did 20 ounces, right? Because that's a venti. But that's okay. We'll do 12 ounce. Again, 30 milliliters. But this is what, one and a half cups. So this should be 360 milliliters. But let's just double check. 12 times 30 is 360 milliliters. So this person got a lot of fluids in their breakfast, okay? Or lunch, I guess, because it's turkey sandwich. So 2 gelatin desserts. So 2 times 2.5 ounces is 5 ounces. So that's another 150 milliliters. A pint of chocolate milk. So you should know that 1 pint, and I'm just going to abbreviate that, is equal to 2 cups, which equals 480 milliliters. And that was in the, if you scroll up, or if I scroll up, you can see pint, 2 cups, 480 ml. And then 1 quart is the same thing as 2 pints, which is the same thing as 4 cups, which is the same thing as 960 milliliters. So if you have a liter bottle of water, you'll usually see it like, sometimes it'll say like a quart, cup, it'll say ounces. You'll have some different things that are listed there. But that's how you build this up. And then all you do is add those all together. So 240 plus 360 plus 150 plus 480 plus 960. And we get 2,190 milliliters. Now, here's where I'm not 100% certain on this. So would you write 2,190 milliliters or we can even say, I'm just going to leave it at 2.19 liters. I might be tempted to round that up to 2.2 liters. But that's where there's, again, some nuance. But we can all probably agree that this person's going to need to go to the bathroom pretty soon, depending on how quickly they consume this. I'm just going to look something up real quick. Give me 1 moment. So let's go ahead and look at some of these flow rate type questions. And the reason we're going to look at these is because that's going to be the new thing that you're seeing for the first time. So let me clear out some of these things that I've written out. And if you go to the Allegheny campus review sheet, there are more flow rate type questions that you can practice. A lot of them I just copied and paste from here. The thing that usually will kind of trip nursing students up as they're going through this for the first time is there's not like an ordered over have. There's not really much of a calculation as much as it is just setting up and maybe making a conversion like minutes to hours or something like that. So I always start off with this Ringer's lactate question, the 375 over 3 hours question. And I'm going to start off by just giving some details. And the reason I start off with this one is because it's kind of like standard, and then we look at some of the other nuance type questions. So when we talk about a flow rate, what does that mean? Flow rate just means some volume over some time. And you're familiar with rates because if you drive a car or if you've ever ridden in a car, you know that the car goes 40 miles per hour. So you're familiar with a distance over time, which is a type of rate. When we talk about flow rate, we're talking about whatever the volume is. Okay. So if you are drinking, uh, a 20-ounce bottle of soda, pop, whatever you guys call it, you're going to um, you can say like, okay, well, if it takes me, 5 minutes to drink that, then I add 20 ounces in 5 minutes. You could calculate a flow rate based off of that if you wanted to. And you can base it off of ounces per minute or ounces per hour, whatever the case may be. Also, pretty impressive if you can do 20 ounces in 5 minutes. Maybe not your best choice in consumption. Water, fine, but I mentioned pop. Anyways, so flow rate is typically going to be measured, especially since you may not always be given what units you're looking for, is milliliters per hour. That seems to be the standard for infusion pumps, is that it'll be listed at milliliters per hour. There's another type of flow rate called a drop rate. So it's a type of flow rate. So I'm just going to kind of put like a little aside down here. And the drop rate is rated in or measured in drops per minute. And drops is abbreviated GTT. And as a reminder, we don't abbreviate it DR because that is already the abbreviation for a unit of volume known as droms. Droms are, if you have perfume like laying around the house, you will typically see that that listed on there. It'll say like it's 1 dram of whatever the perfume is. It's an apothecary unit. They have since gotten away from that, at least in the United States, and I'm assuming in other countries as well, where they're getting away from the apothecary terms, although you might still see it exist in certain let's just say outdated materials and questions and things like that. And then at some point maybe you do need to know how to do that calculation, but you won't need to worry about it for these classes. And that's been the case since I have been doing this, and that's been since like 2012, I think, is when I started doing these drug calc reviews. So they had already gotten rid of the apothecary units. Anyways, that was just a long way to tell you that that's why GTT is the unit for drops. All right, so let's talk about this question here. It says patients to receive 375 milliliters Ringer's lactate over 3 hours. Then what would you set the infusion pump to? And then, so sometimes that might be all it says is what would you set the rate of the infusion pump to? And it won't tell you milliliters per hour. Okay. So if I'm doing this, I'm just going to take, again, because we're calculating a flow rate, 375 milliliters over time. And then I'm just going to reduce it. So 3 goes into 375, 125 mil per hour. There's nothing that we need to convert. We don't need to incorporate the day of the week, how long it's infusing for. We're just wondering, you have the patient set up, they've got an IV inserted. Your orders are to administer 375 milliliters of Ringer's lactate over 3 hours. We can assume 375 milliliters or more in an IV solution, and you're going to turn it on for 3 hours. And in order for that to disseminate or to enter into the patient in the prescribed time, you would set the pump to 125 milliliters per hour. Yes, so someone's asking. I'm going to actually work through all these flow rate questions, and then of course, if you have other questions or there's another type of question, you're like, oh, could we look at that? Like Mara had mentioned the intake question. Just type it into chat, and I will cover it. But yeah, my intention is to go through each of these flow rate questions I have listed here. All right. So speaking of that, let's talk about the next one. All right. So this one is going to also be talking about flow rate, but they're giving you some other information. So I actually think that this might actually be a confusing question. So let me just look at it real quick and make sure I can answer it too. So 250 milliliters running at 100 milliliters per hour. What is the flow rate? Well, so unfortunately, this is a bad question. So, because the answer would just be it's running at 100 milliliters per hour. So I don't know that this was I don't know if this was supposed to be asked a different way. Let me show you another way that we could have asked this. So I'm going to change this question. I'm going to change this to how long will this infusion run for in Okay. So I'm changing the question because we can't really do anything with it. But since I changed it to how long will the infusion run for, we can now do a calculation. So how would we do this? So this is something that you probably have thought of. And this is what I was alluding to earlier when I said, like, if you have a 20-ounce bottle of water, let's just do it with water, and I drink that down in 5 minutes, very, very easy to do, especially if you're thirsty, then you're going to, you can make a calculation, and then you can also know how long it took because you already know the end result, right? You know it took 5 minutes. But let's say you get in there, you know that this person has like a small IV, 250 milliliters, and that it's running at 100 milliliters per hour, and you want to know when is it going to stop. So what we're going to do is, and what I'm going to do is I'm going to set this up using dimensional analysis to answer that question. Now, if you use something other than dimensional analysis, that's perfectly fine. It'll work out. You can you can do like ordered over available to some extent with this one. I would just caution you when you're doing that, and just make sure that when you are doing that, that you are being consistent with the answers that you get. One of the things you don't want to do is get that answer and then end up being wrong some of the times because you put the number in the wrong position. So the way I'm going to show it to you is hopefully what I consider a foolproof method by using dimensional analysis. The problem is you and I would be considered fools if we don't know how to use dimensional analysis. So if you're getting the right answers, don't worry about what I'm about to show you, but just you can use this as a strategy. So what I'm going to do is I'm going to actually start off with the total volume, which is 250 milliliters. Okay. And I can say that's over 1, just so we have some consistency with when I make my conversion factor. So since I'm looking for time, I'm going to take my volume and my flow rate that's listed, the 100 milliliters per hour, and I'm going to invert it. Okay. And the reason I'm doing that is that way I can eliminate milliliters. For those of you doing ordered over available, you're doing the same thing I'd be doing, except you just put 250 over 100. And that's perfectly fine. As long as that number is 1, it'll always work out. If it's a different number, just make sure you account for the fact. So if it was 2 hours, if it was 4 hours, if it was 30 minutes and it's asking you to convert it to hours, just make sure your units are correct. So 250 divided by 100, and someone already answered this, it's 2.5 hours, right? And then we would want to, in order to answer the question most correctly, we'd want to say 2 hours, 30 minutes. So this infusion will be done in 2 hours and 30 minutes. I think most of us, and I mean, I've never, if you don't know this already, I'm a practicing chiropractor. I'm not in a hospital setting at all. I just happen to be really good with this math stuff, and then I've been working with the nursing departments since 2008. But I'm not in your field, and so, but when I had 3 kids, I was there for all their births at Mercy Hospital, and I knew that when the IV was starting to get low, there was like an alarm. And sometimes that alarm was silent, and it was just going off on the computer. But those are things that I notice as, a lay person who's not in with all that stuff. So you get alarms, but this is for practicing your math skills, obviously. All right, here's another flow rate question. I'm actually going to change this up because this was asked previously. Um, and the reason I'm changing it up is because the 90 minutes, you can easily just sit there and go, oh, okay, that's 1.5 hours. But when we make it 45 minutes, you may not know off the top of your head that that's 0.75 hours. And then if you're hearing that, you're like, wait, what? Right? Because that's 3/4 of an hour, right? 45 minutes is 3/4 of an hour. So if you got that down, great. If not, let me show you how you would do this. If it gives you minutes, all you're going to do is convert it to hours. So again, we're doing a flow rate question. I have a volume of 120 milliliters. I have a time of 45 minutes. All I'm going to do is convert minutes to hours. 1 hour, is 60 minutes. So if you're doing this with your calculator, and this is how I do this, after I set it up, I take 120 times 60, and I get 7,200. I don't do anything with that 7,200. I just leave it in the calculator. And then I hit divided by 45. And when I do that, I'm going to get 160 milliliters per hour, as someone also mentioned in the chat. Okay. So if you ever get stuck, and then you could have done, if I take 120 divided by 0.75, I get the same answer, 160. If you're ever wondering, like, will that be the same answer? Yeah, it's the same answer. But some people don't like to deal with decimals. So I'm trying to show you alternative ways to do that. If it was 40 minutes, I would do the same thing, right? I would do 120 times 60 divided by 40. The only thing that's really going to change on these types of questions is the volume and the time, and then what you're going to have to convert it to. I'm going to, because I did this 150, 35 minutes last time, let me change this up. Let's do 175. And then let's make this interesting. Let's say 28 minutes, just because it'll make you work through it. So go ahead and you have a patient that's receiving tube feeding, 175 milliliters in 28 minutes. What would that be? What would the flow rate be? And again, if you want to try an answer, but you're not 100% certain, just send it as a direct message. Only you and I will see it, and I won't call out your name. All right, there's a couple of answers coming in. So just to kind of confirm what some of you are writing out, I have 175 milliliters over 28 minutes. I'm going to convert minutes to hours. And then what I'm seeing as a consistent answer in the chat is the 375 milliliters per hour. So good job. Good job. All right. I think you can do this last one, the 800 milliliters, 8 hours. Let's go to a drop factor question. And then let me give you a couple other examples, or at least one other. Okay. So for a drop factor question like this, I'm just going to change up some variables here. Okay. So as I mentioned before, another type of flow rate is called the drop factor. And if you're doing or drop rate, I'm sorry, another subcategory of flow rate is the drop rate. If you are doing dimensional analysis, all this stuff makes sense. Oh, okay. So just real quick, just as an aside, someone asked if the practice tests are very similar to the tests we're going to take. I do not have a practice test for Boyce campus. So the practice tests that are listed on the Allegheny campus, I can say yes, they are similar, and very similar as far as the content. All I can tell you though is on these practice questions that they are in line with the blueprint with the types of questions you could potentially see on your test. I would say that the thing that might differ is you need to know, and you knew this from what you saw in 110, you need to know that they're not going to give you the units necessarily. You're going to need to know what those are. So if you are, it'll say, how much would you administer? You need to know milliliters. You need to know capsules. You need to know tablets. You need to know, if it says, what is the flow rate? You need to know milliliters per hour versus drops per minute. You would be responsible for that. Sometimes they're going to give it to you. What's kind of like this intake question, right? It just says total fluid intake. So what are you supposed to write? Are you supposed to write it in milliliters? That's what I would do, just because that seems to be consistent with the other types of questions. Or do they want it in liters if it's a number that would qualify as being in liters? So my guess is that they would want it in milliliters. Unfortunately, I'm not the one to make that determination. You would just need to know that from the standpoint of what your lab instructors have told you, and how they want you to answer those questions. Okay, good question. All right, so let's talk about drop rate. So you can use dimensional analysis. In fact, the formula I'm about to share is just basically, it's just dimensional analysis. But when I'm calculating flow rate, what I'm looking for is drop rate. I'm looking for two pieces of information. I'm looking for flow rate, preferably milliliters per minute, and I'm looking for my drop factor, which will be given to me, and its units are drops per milliliter. So you'll notice that the drop factor here just says 20. So you need to know that it means 20 drops per milliliter. If it doesn't give you a drop factor, two things. if you're looking for the word microtubing, if it says the word microtubing, then you know you're dealing with a 60 drops per milliliter type of microtubing is what that's called. And basically all the drop factor tells you is for that tube, how many drops equals 1 milliliter. So it's your conversion factor, okay? But you need that in order to calculate a drop rate. If you don't have that information and it doesn't say microtubing, then they're probably asking about flow rate, meaning they want milliliters per hour. So it's a way to kind of suss out what are or how do they want you to answer that question. Like this one here just says, what is the flow rate? So we can easily calculate a flow rate doing volume over time, but we can also calculate a drop rate, which is what I think this question is asking for. All right. So flow rate times drop factor is going to give me my drop rate. And my drop rate is going to be measured in drops per minute. Previously, and if you watch any of my older reviews, even the one on Tuesday, I'll say milliliters per hour is our flow rate. But let's get down to the nitty gritty. When it comes to drop factor, you want to just start off with it already being in minutes. That way, there's no guesswork as far as, or it saves you an extra step. What I mean by that is, let's say it tells you it's infusing at 150 milliliters per hour. Just right off the bat, do 150 ml over 60 minutes. That way, you're already in the format that you want to be in, and it just saves a step. So, what is my flow rate here? My flow rate for this question is 50 milliliters per 15 minutes. Now, you may be wondering, well, what about that 6 hours? Well, 6 hours just tells us when we're running the order. So it's kind of like saying, take 2 tablets twice a day. That means 2 tablets now and then 2 tablets 12 hours later, right? So that's what this is saying. We're going to run the infusion 50 milliliters for 15 minutes. 6 hours later, we're going to run the infusion again. Okay. So the 6 hours doesn't mean it's continuously running. It just means that every 6 hours, we're going to turn on this infusion for this particular medication. So 50 milliliters over 15 minutes. Then I'm going to multiply by the drop factor. And for this one, it's 20 drops per milliliter. And those of you who've been on my reviews before, you know I like to write these things out. That way, before I do any kind of math, I can see that I'm already in the right units, drops per minute. Okay. Then you're going to get an answer of 66.66666666. We can't give somebody a partial drop. So this would be the one time where when it comes to rounding, we need to round to the nearest whole drop. So you should get 67 drops per minute.
Hey, Dr. Rod. I was doing
Try the second question, the 45 milligram gentamicin, and see what you get, and then we'll confirm or deny your answer. All right, answers are coming in quick. Yeah, I'm seeing that spell check is not our friend on the chat. So you should get 90 drops per minute. I'm seeing a lot of gets and gots, but that's because of spell check. So hopefully Oh, it's not. That's funny. The 90 drops per minute is what we're looking for as far as drop factor is or drop rate is concerned for this question. You may have noticed that I did not do anything with the 60 milligrams or the 45 milligrams. And the analogy I use to express why I don't do anything with the 60 milligrams or 45 milligrams is because it doesn't tell me, that doesn't have any variation when we're talking about a flow rate type of question. And so the bad analogy I use is, let's say we're going to Kennywood and your family takes a minivan and my family takes an SUV. Doesn't really matter what we're taking because our rate is probably going to be about the same depending on, traffic conditions, speed limit, construction, all that kind of stuff. So the flow rate doesn't matter what vehicle you're in or the rate of speed that you're going. Same thing goes for the flow rate. It's important that we have the right medication, obviously, for the patient's sake, and that we're following that order. But as far as calculating the flow rate, we don't need to incorporate that information to get us to the answer that we're looking for with flow rates. All right. So those are some of the examples of the flow rate and drop factor questions. The last thing I will mention, and obviously last thing that I have like prepared as far as telling you guys, is this as a reminder, these reconstitution questions. Remember, in a typical label, it's going to tell you that it's
Dr. Rad, I have a
tablets, capsules, or if it's an oral suspension, milliliters, right? So you might remember like a medication like Dilantin. Dilantin has a strength of 125 milligrams per 5 ml. That's one example of that. Or like heparin is, 10,000 units per milliliter, or whatever it happens to be. There is a relationship between the strength and the volume. When you're dealing with these reconstitution questions, though, sometimes, or I'm not sometimes, but these types of questions, you'll know that you're dealing with one because it'll just say the strength, 500 milligrams, but it won't say, um, 500 milligrams per what. It doesn't say that. And so that's your clue to look at the label and look at the instructions on the side. And ultimately, what you're looking for is this, what is circled in the thing is in the instructions, it tells you that it's 225 milligrams per milliliter. After it's been mixed, after water's been added to the powder, now we have a 225 milligrams per milliliter. And that's the information you want to use when you're doing your calculation. And then all I do is I take my order, I converted it to milligrams because my availables in milligrams. And so this is, I did ordered over available. So 375 over 225 times my quantity of 1 milliliter. And I got an answer of 1.66666666. And then I would just change that to around that to the nearest tenth to get 1.7 milliliters. The way that this is probably going to be asked on your test would be very similar to what you saw in 110. They'll give you the order, they'll give you the available, and they'll say, how much would you administer? So they probably won't include the word milliliters. It'll say you're expected to know that because it's an intramuscular medication, that an injectable means that it's going to be measured in milliliters. So, all right. So that's what I thought was most important to review and prepare you for. But if you have other questions, let me know. Like I said, you can unmute or just type it into the chat. You want to see such and such type of question, just let me know. Or if you have a question about rounding, whatever happens to be, let me know what you have a question about.
Hey, Dr. Rad, can you hear me?
Dr. Rad. I don't think he can hear any of us.
Yeah, I mean, I've been trying to talk, but I don't think.
Dr. Rad.
um,
Chris. Okay.
Who called Kaylee?
I'm not hearing anything, so hold on one second. So
That's funny.
I know I have my volume up. Give me 1 second.
Can I say Marco?
If you're talking, you might just need to type into the chat. I'm sorry. I don't hear anything. I'm sorry. I don't know what's going on with that. It's weird. Okay, I think I can hear you now.
Do you hear me, Dr. Rapp?
I can hear you now, yes.
Okay, go for it, Christine.
Yeah, so I had a question back there when we were doing the flow rate. I'm sorry to take you back. I was trying to talk and I was like, oh my God, I don't know. So I was trying to do these questions and I was looking at some questions that incorporated us using the 24 hours and it kind of threw me off. I don't know when do we use it when it's when you know it's included in the question. How do I know to use 24 hours into the answer when I'm calculating the question?
So do you have a sample of that question?
I don't. I was on ATI.
Okay, so here's what I'll recommend you do, and if you send this to me, take a screenshot if you could find that question and email it to me, and then I will do a separate video on that. So
Okay.
my it depend like the way the question is asked will be dependent. So sometimes that question is actually I don't even want to guess because I'm not entirely sure what the question is referring to. But if you send me a screenshot, I'll put my email in the chat, and then that way you can send me a screenshot or a sample question because I just don't know. I don't know how to answer your question because none of the questions that I went over has anything to do where you would incorporate 24 hours.
Okay.
But someone did mention that the on Tuesday that they said that they had did something with 24 hours, and I was like, well, you wouldn't do anything with 24 hours with the questions I had listed. So, but
Okay.
it makes sense that ATI asked a different type of question. So
That
All
was
right.
on
Yeah,
Tuesday,
thank you.
Christine. It is confusing as heck. I'll tell you that.
Yeah. All right. Thank you.
you're welcome. And the questions that I've put forth as review questions for you all is that is a very similar format to what you should see on your tests. I just don't know specifically if there's anything that has to do with like 24 hours. That's the thing. I'm not 100% certain on what you're even asking me. That's why I can't answer your question. But that doesn't mean that that it's not a potential question because it is a flow rate type question. I just need to see what it looks like to give you better information. All right. So yeah, now that I can hear you guys, please, if you have any questions, just let me know, or like I said, type it into the chat.
With like grounding sometimes IVs and sometimes oral meds.
Okay. So when it comes to rounding with your oral meds, like, are you talking about like where your answers in milliliters?
I believe so.
Okay. Yeah. So anytime, as long as it's something like liquid, they want you to round to the nearest tenth. Unless it's a number less than 1, then you round to the nearest hundredth. So like if you get an answer, let's say your answer is 1.75 milliliters, that's your final answer, then you would round that to 1.8 milliliters. If you get an answer that's 0.75 milliliters, that's your answer. You don't round that to 0.8 because they are looking essentially for two significant numbers if they can be. Now, sometimes you might get a solid answer of 3 milliliters. That's what it is. But if you get 0.25, that is your answer. Don't round that to 0.3. And then the same thing for flow rates. You can round to the nearest tenth that may not be true in a clinical setting, meaning that you may not be able to program into the infusion pump 120.5 milliliters per hour. But on the math test, that's what they're looking for you to do, is get it to is round to the 10th.
What about that one that we just did with the gentamicin that it was like 6.66.66666 and so on? That one was round to the whole number.
Right. And the reason that is rounded to the whole number is because you can't give somebody a partial drop. Okay. So the drop either comes or it doesn't. It's kind of like a tablet, or it's kind of like a capsule. You give them a capsule or you don't. That's the option with a drop. So like I can't give somebody 1.5 capsules, right? I have to give them 2 capsules because I can't separate the capsule and expect that I'm going to get exactly half the medication. Of course, we probably all have family members or people we've run into that are like, "Oh yeah, I just do a half of." They're doing it wrong, right? So you've learned that at least at this point. So that's the rule with a drop. So like let's say if I had it set to dispense at 66.66666, 66 drops would come out, and then that last drop wouldn't come out because I can't just do like a little bit of a drop. I hope that makes sense.
It does. And also, when it comes to like a 5, like I've seen sometimes that we round up to the 10th, or we round down or round up with the 5. When it comes to a 5, like 75, you know what I mean?
Okay, so like if I have like let's just go back to drops. If I have like 60.5 drops per minute, you're going to round that up to 61.
Okay.
And if it's 60.4 or less, then you would round it down to the 60.
Okay.
And then I always say, like, I have a feeling that in a true clinical setting, that the real answer to that is you may not even be able to program it other than in increments of like 5 or 10. So it might only be like you can only program 20 drops per minute, and then 25, and then 30, depending on the way the infusion pump is set up. So that's the other thing that we don't know. But from a math standpoint, that's why we do what we do.
All right. Well, thank you.
Yeah, you're welcome. All right. Christine, if you're still here, I'm going to type into the chat a sample question that I got from registered nurse RN. Is this something like you're seeing on where maybe it says instead of infuse over 48 hours, maybe it says over 24 hours? Is this something you're seeing?
I'm sorry, what did you say?
Okay, in the chat, I put in a sample question. Is that similar to what you're seeing on ATI? And if you can't see the chat, it says doctor's order says 2 liters of dextrose, 5% water, half normal saline to infuse over 48 hours. What is the hourly rate? Is that similar to what they're asking on ATI?